Hey everyone, today let's try to solve another LeetCode problem. This problem is called find the safest path in a grid. So in this problem, you are given a matrix n by n in dimension, which means this is a square matrix. Each cell in the matrix can be 0 or 1. So 1 means there is a div on that particular cell, while 0 means there's no div. So what does it mean to have a div? If there is a div, it means that it can steal you while you walk near that cell. Our goal for this problem is to find a path from 0, 0, that's also what is your starting point, all the way to n-1, n-1, which is your ending point, which is also the bottom right. So basically you're trying to go from the top left to the bottom right and find a path to it. And each time you can go 4 directions, left, right, up, and down. So in this particular example, there is a div in here. And our goal is to go from top left to bottom right. And we can pick this particular path, which will give us the answer. So what we have to return is just return 2. So why is 2? Because in this particular path, which is the optimal path, at one point, which is the starting point in this case, the div here will take 1 step and 2 steps to steal your thing in this path. Well, because you have to go from 0, 0 all the way to the n-1, n-1, so no matter what other path you choose, you would end up having the div being able to steal you at 2 steps. So that's why the answer is obviously just 2. Of course, you can choose a worse path. For example, if I choose a path here, then the div can steal you in 1 step. But in this case, the safety number will be 1. But we want to achieve the maximum safety number as possible. So that's why we should return 2 in here. So for this particular example here, we want to start from top left all the way to bottom right again. There is the path that we can choose. The answer is 2 again. As you can see, there are 2 divs on the graph. One is in here and one is in here. If we take this path, this div will take 2 steps at this point to steal your thing. So that's why the safety number is 2. And it can also go from here to steal your thing in 2 steps. You might say, why don't we pick another path that is further away from this div, like this path? But in here, you can see there's another div in this position. If we pick another path like this, it will take this div 1 step only to reach you. So the answer will become 1. But there is an optimal path here, which is using this path. Then we can go from all the way from 0, 0 to n-1, n-1 with the safety number as 2. So what we want to return is the maximum safety number as possible. So that's basically all for the problem description. Let's think about how to solve it. So let's consider a technique called binary search. Let's think about what does it mean if we fulfill the safety number of x. As we mentioned, if we fulfill the safety number of x, it means that any div will take at least x steps to steal you. So basically there exists a path that any div on the grid will take at least x steps to steal you. For example, here, let's say this path is the optimal path, going from the top left all the way to the bottom right. Then every div will take at least X step to steal you. What does it mean? So if we fulfill the safety number X, then let's think about X minus 1. So now if we think about X minus 1, it means the div can move one last step. So we can still use this path, but if the div or the divs cannot reach any of your point in X step, it is even more hopeless for them to reach you in X minus 1 step. So what I'm trying to say is that if this is the safety number that we are checking, let's say we OK means there exists a path for this safety number, and we don't actually have to consider anything that is less than it, because if there exists a path on particular point here, then it means everything will be okay in here. And also we still need to consider another condition, is that when it is not okay. So when it is not okay, it means that we have considered every path using some kind of method, then we can be assured that no matter what path I choose, some of the div will be able to reach me within X step. So if X is already not okay, then X plus 1 means any of the divs will have even one more step to reach me. So if this is not okay for X, and X plus 1 all the way to the high boundary will also be not okay. Combining these two properties means that we can apply binary search on it. If the middle one is not okay, then we don't have to check the right one at all. We just have to check the left part. And if the middle one is okay, then we don't have to check the left part at all, because they will all be okay. And we just go to check for the right part. That's why we can apply binary search on it. So the lower boundary of the binary search is 0 in case there isn't any safe path from the top left to the bottom right. Usually if the div is occupying the 0, 0 or occupying the n-1, then we will have 0. For high, let's imagine how can a div reach you in certain steps. At most, it will take n plus n step. So that's why the low boundary is 0 and the high boundary is n plus n. The second question becomes how to tell if safety number X in particular is valid or not. So let's consider using breadth-first search. For each div, we want to block anything that is within k distance, because if your path reaches any of the cell that is within x distance of the div, it means the div can steal your thing within x steps. That's why we want to do it another way around. We want to block everything that is within x steps from the div. After we block it, we want to check if there is still exists any path from the top left to the bottom right. If that exists, then we return true. It means that we can reach this safety number. But if it is not, then we return false, because after blocking all the cells that are within x distance of every div, we cannot find a path. So that means we cannot fulfill that safety number. Then we will return false. So that's pretty much all for the overview of that solution. Let's take a look how can we actually solve it in code. So first, we're going to initialize n as the size of the grid. Then we're going to create the range of the binary search. As mentioned, the range will be from 0 to n plus n. But we can just initialize the answer as 0 and then search the range from 1 to n plus n. If there exists a better answer than 0, then we will just replace it for the larger answer. Then we will initialize the 4 directions that we can go, which is up, left, right, down. And then this OK is the helper method that we will use for our binary search. It basically means that if it is fulfilling the safety number x, so if the grid can fulfill the safety number of x, then OK will return true. Otherwise, it will return false. Line 8 all the way to line 25. We are going to run a DFS for each div. And then we will run the DFS loop for X amount of time, basically blocking any cell that are within X distance of any div. Then, if the starting point is already blocked, then we just return false. And otherwise, we will try to find a path from 0, 0 to n minus 1, n minus 1. If there exists a path, then we will just return true. If there doesn't exist the path, then we will return false. After having that OK helper method, then our binary search code is actually very simple. We just need to find the largest possible safety number. If it is safe, it means we can reach this mid as the safety number, and we will replace our answer to here. And then we're going to find an even bigger answer. And if the current safety number is not okay, as we already explained, x plus 1, x plus 2 will also be not okay. That's why we don't even have to bother looking at them. We just need to look at the left-hand part. That's why we set the high boundary as mid minus 1. After doing all the binary search code, the answer will be what we want to return, which is the highest safety number that we can reach. For the space complexity, we only used n squared, mainly come from this blue 2D matrix and this scene 2D matrix. For the time complexity, for starter, we have to consider this binary search while loop. We know the high bound will be n plus n, and the low bound will be 1. So basically, it is O log n. But that's just the first part. How about the second part, which is the OK helper method? So for each log n, we will have another n squared, because we have to do order marking for every cell, potentially visiting every cell in the matrix. And also creating this block array will take us n squared time. So the time complexity will be log n times n squared. So that's pretty much all for the solution and the code implementation. I hope you find this helpful, and I will see you next time. Bye-bye.